Hi, and welcome to the lesson. In this lesson, we're going to talk about TCP and IP basics, which is really the introduction to IP networking. We have a lot of good information to cover about TCP and IP networking and a lot of good information to go over. So let's go ahead and get started. IP networking or Internet Protocol and the TCP standard or protocol. It's one of my favorite areas to go over with the A plus. A lot of what you do as a technician in the field would generally circle around IP networking and the devices that's connected on our IP networks. So it's very important that you get the fundamentals to this portion of the A plus exam. IP networks are everywhere in our lives today. They are a critical foundation of the communication of our devices. Everything that we have that's on the network is ran by the TCP IP protocols from our home routers, our Wi-Fi devices, smartphones. IP, TCP IP is a key element that moves our data. So that's why it's so critical and so important. But this is a great topic to learn, again, as a technician. You have a lot of fun learning about TCP IP and all the networking protocols that's involved with that. So TCP IP is about moving data from one place to another. Actually, TCP IP is actually two protocols. TCP stands for the Transmission Control Protocol, and it's responsible for packaging the data, frames into packets, whereas the IP is Internet Protocol, and that's responsible for addressing. So TCP IP is generally called, IP networking or IP networks. So you hear somebody say IP networking, IP networks, this is generally what they're speaking about, TCP IP and those protocols. So, like I said, TCP IP or IP, Internet Protocol or IP, is moving data from one location to another. So, let's use the analogy of mailing a package from one destination to another destination. So, if we're sending a large amount of data, we use a shipping box to put all that information or things into it. Across the network, we're sending it across a postal carrier's shipping route. So our network and IP, we can relate that to a shipping route on a postal carrier shipping route. So we'll use that analogy. So in Internet Protocol or IP, the mail truck is Internet Protocol. The box or the packet that holds our data that we're sending, that's going to be the package. And TCP or UDP is going to be the type of data that we're sending in that package. And you'll explain more as we break out a little bit further and look at a packet and how it's structured. So if we take a box or a packet and break it apart, this is what we'll see if we can visually look into a network packet going across the network. A network packet or a box has an Ethernet header and an Ethernet trailer. And inside of that is the Ethernet payload. And if we dig in a little further, we'll see that it has the IP has an IP payload. Okay, now stripping that back further to look inside, even more inside the box, we see that this payload is actually it's a TCP payload. And peeling back one more layer, we can see that this TCP layer payload rather is an HTTP data. So that's how a packet would look going across the network. You have again the Ethernet header and the trailer, then you have the Ethernet payload. Inside that payload, you have the IP payload. And if you look inside of the IP payload, it'll be TCP what it's sending. It could be TCP or other protocols that we're going to talk about later on in the lesson. In this particular example, it's TCP. So you have a TCP payload. And to look even further to see what type of TCP payload, it's HTTP data. So this could be a client going to a website, and and that website is responding to that client's response, and that packet is an HTTP data packet going either to the web server from the client or from the web server to the client. So this is how a packet will look going across the network. So now that we've looked at a packet or a box and how it's packaged, how do we determine if we send something to a computer across the network and I want to connect to a web server? How do we make it go there and not just go anywhere? So that's where the basics of IP addressing come into play. So, going back to our analogy of a mail truck, the IP protocol or our truck delivers the box, which is the data, to its destination address. So, again, how do we determine the address? Each house has an address, each computer has an IP address, many different addresses, many different locations. So, boxes arrive at destination address, but where do they go? So, if we look at the analogy of this image right here on this slide, the mail carrier has arrived at the location, and there's an apartment. And the mail carrier has an IP address and an address where this box is going to go, but they don't know exactly where in this location that this box will go. And that's where ports come into play. So, delivery of data relies on ports. So the IP protocol truck delivers boxes data to the destination address, and it looks for a IP address and a ports because ports are used to deliver boxes to the application or data to the application. And if you look at the image, there's different numbers there. Those are data ports. So we have in the image port 80, port 25, 443, 587, 53. As you go further in IP networking, you're going to learn these right off the bat. You're going to see 80, and you know immediately that's web data traffic. You're going to see 443, and know immediately that's HTTPS or secure web. You're going to see 25, you're going to know that's a mail server, or 53 is DNS. You're going to know these automatically. So let's look at ports a little bit further. So ports are IPv4 sockets. You know, it's the server IP address protocol, it's the server application port, and the client IP address protocol and the client port number. So going a little bit further on ports, um, some ports are non-ephemeral or temporary ports. Permanent ports numbers can be assigned to certain applications, 0 through 1023. And that's usually on a server or a service. So, give you an example. I mentioned before a web server. A web server is port 80. So we generally know that that server is running a web service because it's using port 80 on that server. Or if we were to look at that server and notice that their port 25 is open, we know that that's a mail service because mail service is running on that server. So, again, going back to our earlier analogy, if I had a box or data moving across the network and it's intended to a mail server and there's 5 servers there, I'm going to be going to the IP address and looking for that port number of 25 to deliver that information there to that server. So ephemeral ports are ports from 1024 to 65,535. So those are temporary port numbers, and those are determined by the client. So TCP and UDP ports can be any port between 0 and 65,535. Most applications on servers use non-ephemeral ports. But that may not always be the case because applications can use different ports. So the application needs to know the new port if it's not going to be using the standard port. A service or application ports are well known ports like port 80, port 25. We know those services and we know what ports they generally are used for those services. Ports are used again for communication and not security. And what that means is, say, for instance, if I had a mail server and I wanted to disguise the port to be something other than 25, that is not necessarily a security to hide that. That service is still running, and there are ways to determine what that service is. And then one thing to remember that TC ports are not the same as UDP ports. So again, let's look at, we talked about port numbers. Let's look at them in a little bit more detail. So we talked about the web server of being TCP. It was 80. And we're going to throw some more in there. A VoIP server uses UDP 5060. And we're going to talk about a mail server using TCP 143, which is IMAP. That's the service there. So this is how the information will look. So in the first image here on the first box, we have a source IP address and a destination IP address. The source is 192.168.1.20, and the destination is the computer on the right, 192. 168.1.1. Now, the source port can be any port that it's sending from, a random port, but it's sending to a destination port of 80. And 80 is an HTTP data port or a web server. So that packet that I'm sending from my computer to that other computer with a destination of port 80 is web. I'm connecting to a web server there. So let's try it again. For the next one, we want to connect to a VoIP server, voice over IP server. So again, the destination would be 192.168.1.1, and my source IP address is 192.168.1.20. Again, I'm sending it from any port, and it's going out of port 6008 or 6008. But I'm shooting for or aiming, it's going to look for the service on port 5060, which is a VoIP data port. And one more example, my destination is still 192.168.1.1, but my port is going to be 143, which is email data. So again, I can send from any port, 3001, but I can tell the service that data is intended for by the port number. 143 is the email service on that server. Now, these are other ports and protocols that you should be familiar with, and you'll see these ports and protocols and a lot of others in your learning of IP networking. So, generally, you've heard of FTP or the File Transfer Protocol. That's ports 20 and 21. Secure Shell, which is a secure way of connecting through a console to other terminals. That's port 22. Telnet is port 23. We talked about mail or SMTP, the Simple Mail Transfer Protocol, which is 25. Domain Name Service, DNS is 53. These are, again, general ports that are commonly used on services that you're going to be familiar with. Okay, in summary, this is what we've covered in our intro to TCP IP basics. We learned about the TCP IP protocol. We learned about Ethernet packet structure, IP addressing, and ports and protocols. Okay, thank you very much for being with me in this lesson. We covered a lot of good information, and we got a lot of good information to go as your journey continues on the A plus exam. I'll see you in the next lesson.